Welcome to Robotics for February the 11th. As I mentioned right before I turned on the recording, we're going to be talking about a lot of important stuff today. And so I think it's worth recording the session. And then at the end of the session, I'll ask you guys whether or not you want me to post it. But I do see there's two people who aren't here. So maybe we should just go ahead and plan that we will be posting this one on Canvas. All right, so because of the big conference that I was attending, I wasn't able to meet you on Tuesday. So what I want to do first is I want to go over the homework that was due on Tuesday, and or actually it was due on the Saturday night before is when it was actually due. But I want to talk about that. This was the assignment. In fact, let me go ahead and share my screen here. Okay, the assignment that was due on Saturday was this one here about downloading and reading the Arduino primer. Okay. And so what I asked you guys to do was just to read the primer and then come up with 3 questions that you had that the Arduino primer did not answer. And I was really pleased with what I saw. You guys, the questions that you came up with are important questions that you need to know. And I agree that the Arduino primer did not deal with those questions. So what I'd like to start out the class with is I'd like to go over the questions that some of you asked, and let's talk about the answers. So let me share my screen with you. Not that one, this one, okay. All right, so these are just a few of the questions. I have others that I'm going to go over later. So actually, several of you asked me the question of who created the Arduino. All right. Well, the answer to that is it was a team of engineers who work in Italy. The lead guy was a guy named Massimo Bonzi. I'm sure I pronounced that horribly wrong. Please forgive me, Mr. Bonzi. But yeah, it was a team of Italian engineers. And in my opinion, these guys deserve the Nobel Prize because I think the Arduino is one of the best inventions of the last century. It is so incredible to help people learn how to program, help people learn how to use electronics and motors and robotics in general. So, wow, congratulations to our friends in Italy. Good job there. Okay, so how do you make an Arduino remember a program? Okay, well, once you upload the program to the Arduino, it remembers it. Even if you turn off the power to the Arduino, it still stores it. It's just like your phone. When you store a photograph or whatever in your phone, even though you turn off your phone, the phone still remembers it. Yeah, so there's a special kind of memory that can retain the memories even without power. So Arduino works the same way with that. This next one here, how can you turn on an Arduino without plugging it in? And yeah, that one's an interesting one. In fact, I should have pulled one out here. So in your kit of parts, rats. I should have thought to get one. Okay, unfortunately, I don't have one with me, but in your kit of parts, there's a little, oh, here it is. Here's one. Okay, hang on. Okay. There's a 9-volt battery, and then there's this little adapter here for the 9-volt battery. So what you do is you plug the 9-volt battery into this adapter, and then on the other end of the wires here. Now the one that I have is different than the one you have. The one that you have on the other end of this wire is a plug, and that plug fits into this port right here on your Arduino. So if you just plug that into the Arduino, then you don't need to be connected to the computer anymore. Now, this is assuming that you've uploaded the program first, okay? So you have to be connected to the computer to upload the program. But once you've uploaded the program, you can then disconnect from the computer, The Arduino will remember the program. And so if you want to run the Arduino, you just take this 9-volt battery, plug it in right here, and your Arduino will come alive and it will start doing whatever it wants to do just based on this little 9-volt battery. And that's going to come in really handy, because one of the things I'm going to have you guys do very soon is I'm going to have you guys making things like this. This is a cardboard box that's got wheels on it. And if you open it up, the cardboard box, and look inside, what you'll see is that those wheels are connected to motors, which I've got attached to the sides of the box. And I've got a little battery in here to give me power. And right here, I've got an Arduino. Now this Arduino, it has a special thing attached to it that we're going to talk about later. So what you need to do then is just take this guy, put him in here, plug him into the Arduino, and then you can close this thing up, okay? And this thing will now run around. It'll drive these wheels. And on the front here, I've just got a plastic spoon, okay? So I set this on the table, and this thing will run around the table doing whatever I've programmed it to do, even though it's no longer connected to the computer. It's completely self-sufficient. Everything that you need is inside this box. So this is something that I'm going to have you guys do very soon. Not today, but very soon. Okay, so somebody just sent me a private message asking, does the Arduino only remember the most recent code that's uploaded to it? And the answer to that is yes. And that's kind of unfortunate. It would be nice if the Arduino could remember a whole bunch of different programs and you just tell it which one. That would be a really nice feature. But unfortunately, that's not the way it works. Once you upload a program, all of the previous programs are gone forever. But hopefully they're still in your computer, so not too hard to upload them later. All right, let's go back to here again. Okay, so next question was, why can you only use 5 volts on the Arduino? All right, answer to that one is basically just history. Over the past several years, a whole lot of electronic devices were developed that work off of 5 volts. So the powers that be, the people who really understand electronics, they got together in a big conference and they said, we need to have a whole family of electrical components that can all work together. And it's only gonna work out if everybody uses a common voltage. So they got together at this conference and they voted and they said, what do we want this common voltage to be? And so everybody said 5 volts. And so thousands and thousands of electrical components were all developed, but they were developed to run off of 5 volts because that's the voltage that they had agreed they were going to use. So that's why the Arduino uses 5 volts. But more recently, the people who do this conference, they all got together again and they said, okay, well, it's been several years now, and we want to have a new family of devices, and we want to use less power. Well, it turns out that if you use less voltage, then you use less power. And so your battery can last longer. And so new devices are being made now that work on 3.3 volts. And in fact, if you look at the Arduino, down here next to your analog pins, there's a 5 volt pin. There's also a 3.3 volt pin there as well. So the people who developed the Arduino, they recognize that there are some components out there that run off of 3.3 volts rather than 5 volts. And so the Arduino does have a 3.3 volt pin specifically to handle those newer components. Now in this class, we're not going to be working with those newer components. Everything that we do in this class, we're going to work with that older family of components that are designed to work off of 5 volts. Okay. So I hope you guys are finding this information useful. It will come in handy. So is there a kind of Arduino that allows you to use more than 5 volts? No. But there is one that allows you to do things with less. Okay, next question here. What is the GND pin? Okay, so GND stands for ground. And so it's basically the negative side of your battery. So if you think of a battery as, being, it's got a plus side and it's got a minus side. And so the minus side is, that's where we set our reference level. That is always considered to be 0 volts. So that's where we say that the electrical pressure is 0. And on the plus side of the battery, that's however many volts it is. So maybe it's a 1.5 volt battery, maybe it's a 5 volt battery, maybe it's a 12 volt battery. Okay. But when we say that a battery is 5 volts, what we mean is that the electrical pressure on this side of the battery is 5 volts more than it is on this negative side of the battery. Now, a lot of people think that the negative side of the battery, there is no electrical pressure. So this is the negative, this is the plus. A lot of people think that there is no electrical pressure there. That's actually not the case. There is electrical pressure at the negative side of the battery. It's just that the positive side of the battery is 5 volts higher, 5 volts more pressure than there is at the negative side of the battery. Okay. Now, why is this important? Okay, well, because this allows you to connect batteries up together in a technique that we call hooking them up in series. So if I take a battery here, and so this is my plus side, this is my minus side. Let's say it's a 1.5 volt battery. It's like what we call a AA battery. And let's suppose that I want to run something that needs 4.5 volts. And all I have are these 1.5 volt batteries. Well, what I can do is I can just stack them together. And now I need to make sure that I stack them the right way. I need to take it so that the negative side of this battery is connected to the positive side of that battery. Okay, so what that means is that this side of the battery is going to be 1.5 volts more pressure than this side. And then if I connect these guys up together, these guys are going to now be at the same pressure. So this side up here is going to be another 1.5 higher than that, but that's already 1.5 higher than that. So it means this guy right here is going to be 3 volts higher than the bottom. And by the same logic here, this guy up here is now going to be 4.5 volts higher than the bottom one is. So the fact that this is a negative here, that does not mean that there's 0 volts there. It just means that the plus side is 1.5 volts more than whatever you have on the left side. So if you hook up batteries like this, we have a special name for that. We call that hooking them up in series. And when you do that, the voltage adds. Now, for some of you, that might be very important because in a few minutes, I'm going to talk about tonight's homework. And for some of you, this is a trick that you might have to do. So keep that in mind. Okay, so does the computer supply the 5 volts for the Arduino? That's an important question. All of these are really important questions. I'm so glad you guys asked them. Okay, so when the Arduino is plugged into the computer, so when you've got this thing, and remember, whenever you plug it in, always put your finger right here because otherwise you might rip the silver box off. So when you take this guy here and you plug it into the computer, so the Arduino is getting its power from the computer at that point. And so if you want to just leave it that way, you can go ahead and run the computer just fine. But as I said a few minutes ago, if you want to do something like put the Arduino inside of one of these little boxes here, you can't have it tethered to a computer. That doesn't work. Okay, so that's when you're going to use that other battery, the 9 volt battery. And so then you don't need to get your power from the computer anymore. Now you're getting your power from the 9 volt battery. Okay. Okay, next question. What's the difference between anode and cathode? Okay. All right, so anode and cathode. All right, so if you have any kind of a device, like let's say you have an LED, okay? So notice one of the pins on the LED is longer. Okay, so this is this is where the electricity comes in to the LED. Okay, so all the plus charges, They're coming. Let me switch to a different color. The electricity is going to come into the LED here, flow through the LED, and coming out there. Right. So anytime that you have a place where the electricity is coming in, that is called the anode. And then where the electricity comes out, that is called the cathode. Okay, so those are the definitions there. And it's not just LEDs, but any device at all. Whenever you have electricity flowing, okay, wherever it comes in, that's called the anode. Wherever it comes out, that's called the cathode. Okay, does the analog pin control something? Well, on the Arduino, the analog pins are only used as input devices. So if you want to send information to the Arduino, so you want to push a button and you want the Arduino to know that the button has been pushed, or you've got some sort of a sensor and you want the Arduino to read the sensor and then do something based on what it sees. Okay, you feed all of that information into the analog pins. Those are input only. Those are not output pins. So so yes or no, depending on how you define the word control. I mean, if you've got your Arduino programmed so that the Arduino will behave differently when it sees a signal on the analog pin than it does when it doesn't see the analog pin, then, I mean, if you want to define it that way, you could say that it's controlling something, but really the control is the Arduino itself. The analog pin is just where we feed information into the Arduino. Okay, is there a way to expand the number of ports on the Arduino? Well, remember that before you transfer your program to the Arduino, you have to check which board it is. There's a whole bunch of Arduinos, and some Arduinos have more ports. Like the one that's famous, I mean, the one that you guys use, that's called the Uno. But there's another board that's called a Mega. And I have one over on the other table, but I won't bother to go get it right now. It's an Arduino, but it's got way more ports on it so that it can handle a lot more inputs and outputs and things. Okay, next question. Can you hook multiple Arduinos together? The answer is yes. You can have 3, 4, 5 Arduinos and they all talk to each other. And it's very cool. And towards the end of the year, we will do something like that, but not right now. Okay, what's the processing speed of the Arduino? I don't have that number memorized, but it's so fast, it's measured in microseconds. I mean, not milliseconds, but like it's some number of millionth of a second is how long it takes to execute one command. So it's really fast. So in other words, if you're familiar with megahertz, okay, it's definitely measured in megahertz. It's not measured in gigahertz. It's not that fast, but it is measured in megahertz. Okay, a couple more questions. Oops, didn't mean to do that. Okay. All right, so there's some overlap here. So who invented the Arduino? Okay, we already talked about that. Why do some use AC and some use DC? That is a question that is, there's not a simple short answer that I can give you. I mean, there is an answer and I can give you the answer, but in order for you to understand the answer, you would need to know a lot more about physics than you currently know. So I hate to give you a cop-out answer, but basically what I'm going to have to say is wait until you've taken my physics class, and we're going to talk a lot more about it in physics. But there are definitely good reasons. So first off, let's just make sure we understand what AC and DC are. That is worth talking about. Okay, so DC. Let me turn on my annotation here. Okay. So DC is what you get from a battery. So the electricity flows out. So this is your battery. Here's your plus side. Here's your minus side. So electricity comes out of this side of the battery, and then it goes and does whatever you want it to do, And then when it's all done, it comes back in the other side of the battery. And so it always flows one direction. So we call it direct current. Okay. And that's the way batteries work. Now, the electricity that comes out of the wall socket in your house, that works very differently. That flows one direction for 120th of a second, and then it flows in the opposite direction for another 120th of a second. There is a very good reason for why that's done, but if I were to explain it, it would take too long. And so all I want to say is just wait until you take physics, and I promise you I will talk about it there. Okay, so this one we've already answered. Solderless breadboard. So at the time that you asked the question, we had not yet talked about solderless breadboards. But now, hopefully you guys watched the video. And so hopefully when you did the assignment that was due today, hopefully you now understand more about solderless breadboards. So can you guys type into the chat box? I want you to either type yes or no. Yes means that, yes, I do now understand how a solderless breadboard works. And no means that, yeah, you don't really understand how it works. So everybody, please type in either a yes or no. And I see yes with 3 exclamation marks. Wow. Okay. All right, good. So I'm glad to see you guys understand that. So these solderless breadboards are wonderful things. Okay. So we are going to be using these a lot. They are really, really nice. Okay. So we're almost done here. Okay. Why is it that only certain pins can handle PWM? Okay. Well, I'm not sure the history of why they did it that way, but when you're making an Arduino, if you want a pin to handle pulse width modulation, the hardware that goes behind the pin, the stuff that you can't see that's hidden behind there, that hardware is more complex. And so if they wanted to make every pin be a PWM pin, they could have done it, but it would have made the Arduino more complicated. It would have made the Arduino more expensive. And so they decided that they would only do it on certain pins and not do it on others. Okay. Okay, so these next ones here. So this was Zane here. So he knows how silicon chips are made, but he's curious to know how it gets from the thin, almost clear chip into a black bug looking thing. How much detail do I want to go into that? Basically, when you make computer chips, which by the way is what I used to do. I mean, before I retired, that was my life, was making silicon computer chips. Okay. So, and I don't have any with me handy here. If we were at the school, I actually have some of the things that you make computer chips on. It's a big, thin, round disk. And on this disk are a whole bunch of computer chips, and you make them all together in one batch all at the same time. And then when you're done, what you do is you get a very sharp saw, and you just saw it up into little pieces. And so on one big silicon wafer, that's what you call it a wafer. On one silicon wafer, you could have hundreds of computer chips. And so after you've gone through all the process of making it, you just get out a saw and you cut them up in little squares, and you take the little square and you put it inside that plastic, the thing that looks like a caterpillar, with all those legs there. You put it in there and you glue it, and then you solder on the connections so that each leg is connected onto a certain part of the chip. So that's really all the detail I want to go into here. I would take too much time if I went into more detail. Is it possible to make electrons move extremely slowly? Well, resistors will slow down the flow of electricity. So if you use a resistor with a whole lot of resistance, then yeah. I mean, when we measure resistance of resistors, we measure it in ohms. And so we have like a resistor might be 10 ohms, or it might be 100 ohms, might be 1,000 ohms. I have resistors in my collection that are 1 million ohms. Those babies really slow things down a lot. Okay. All right, and then the last question there was kind of an interesting one. If you short circuit a circuit, it smokes up, which by the way is true. And so guys, be careful when you're making your robots. be really careful that you don't accidentally connect the plus side of the battery directly to the minus side without anything in between. If you do that, so let me draw a little picture here. Okay. So if this is your battery, so here's your plus side, here's your minus side, and here is some device that you're powering. Okay, so if you hook it up like this, everything works fine. But if you accidentally hook it up so that the plus side is connected directly to the minus side of the battery without anything in here to slow the electricity down, yeah, it smokes up all right. And it could even, in theory, could catch fire. So Zane's question here is, what happens if you short circuit a wire that's not so bad that it smokes up, but it still is short circuited? Well, what you're going to do is you're going to destroy the battery. Or if it's an Arduino, if you're getting your voltage from an Arduino rather than from a battery, then you're going to destroy the Arduino. So guys, please be careful you don't accidentally. So if you've got an Arduino here, in fact, tell you what, this is a good lead in to what I want to do for today's homework. So let me go here. Okay, this is what's going to be today's homework. Let me just zoom in on one of these Arduinos here. Okay, if you accidentally connect a wire from the 5-volt pin to the ground pin with nothing in between, yeah, you just destroyed that Arduino. Okay, you're going to have so much electricity trying to flow through here that the Arduino is going to heat up, and maybe it'll smoke, but even if it doesn't smoke, it's been destroyed. Okay, so please don't destroy my Arduinos. I would really be grateful if you didn't. Okay. All right, so thank you guys for asking those questions. I think that it's really important that you know the answers to those, so I'm really glad that you did ask them. Okay, so now, what about the homework that was due today? Which, by the way, I see that some of you have still not turned in. Most of you have, but a couple of you have not done the homework that was due today. Guys, what does it take? And there's maybe 2 of you that I'm talking to, and the 2 of you, you know who you are. I've talked to you before. If you guys don't turn in the homework, you are not going to pass the class. You are bright people. You are smart people. Why would you not turn in the homework? What, guys? Wow, I don't understand you. Okay, so the homework that was you needed to turn in was you had to build a circuit, and then you had to show me that it worked. And almost everybody submitted a video showing me that your thing was working properly, but not everybody. So now I'm going to show one of the videos that was submitted, and I'm not going to say who it was that submitted it. So if this is your video, please do not feel bad. I do not think that you're a bad person. You have an interesting problem here, and other people might possibly have the same problem. And so I think it's really good that I'm going to share this video here, but I won't say whose it is. Okay, so you guys should be seeing a copy of, so are you seeing all the video right now? Can you guys either type in the chat box yes or no? Yes means that you're seeing the video, no means you're not. Okay, good. All right, now it's not playing right now. I've got it paused right now. Okay, so watch what happens when we start the video. It's a really short video. Okay, so here goes. I'm going to start the video. All right, so you see the motor is turning, but if you look at the lights, you'll see the lights are not doing what they're supposed to do. Okay, so I'm going to play the video again, and this time I want you to look right here, look at the lights, and you'll see that they're not working properly. So here goes. I'm going to play the video again. Okay. You see the lights aren't lighting up. Okay. Now, I'm thinking that some of you might have enough experience that you can look at what this person has here, and you can tell me what the problem is. Can any of you look look at this circuit. Whoops. So let me go back to here again. Okay. Look at this circuit that you see right here. Can anybody see something that would explain why it's not working right?
I don't think the cathode is going to going back to ground.
That is a possibility. Um, so yes, that could possibly be what's wrong, but there is something that is glaringly wrong, and Zane got it. Yeah, look at what Zane wrote. Okay, the H bridge is connected in there. So now the rest of you guys, you're going to say H bridge. What's an H bridge? Okay, but Zane knows. So this little thing that looks like a caterpillar that's got 16 legs, that is a special type of device which we are going to be using for tonight's homework. Okay, and it is called an H bridge. Okay, and so the person who made this circuit, they plugged in their LEDs into the same set of input pins here where the H bridge was hooked up. And so what's happening is the H bridge, it's absorbing some of the electricity that it should not be absorbing. And so it's making it so that things don't work right. So if you are the person who submitted this video and you're wondering why your circuit isn't working right, it's because of this baby right here. So just go in and just pull him out. So if you, let's see, yeah, I should have grabbed an H bridge before. Okay, unfortunately, I don't have any handy. Okay, but pretend this is it, right? So all you have to do is just reach in with your fingers, grab it, wiggle it a little bit. It's in there pretty firmly, but if you wiggle it a little bit and then pull, you'll be able to get it out. And so once you get it out, hopefully if you don't have anything else wrong with your circuit, you'll find that your circuit will work properly. Okay. So that's one reason for sure why your circuit isn't working. Now there might be other things wrong with it too, but that one for sure, that's going to make it so your circuit's not going to work. Okay, now how about the rest of you here? Okay, let's just take a look at a couple of the other things that you guys submitted, just so that you guys can all see. Okay, so I'm going to go in here to this thing. So this is something that you guys don't have. This is how we teachers grade submissions. Is we have a special feature here called Speed Grader. And so let's not go to that one. Let's go to Scott's. Let's take a look at Scott's. Okay, so here is Scott's video. And here it's loading. Okay, now here I'm going to make it big so everybody can see. All right. So as soon as it loads, we should all be able to see Scott's video here. Here goes. Okay, so notice you can see him turning the knob. And as he turns the knob, you can see that the motor goes faster and you can see that the LEDs light up. So that one LED is so bright that once it gets light, it's hard to see anything else. So don't worry about that. Okay, so we're at full speed. So now he's going to turn it the other way. And you see that one by one, the LEDs go out. Okay, and the motor runs slower and slower and slower. And then when he comes to full stop, it goes off. Okay, so this is perfect. This is exactly what I was wanting to see, was this right here. Okay, so those of you who have not submitted a video yet, this is what I want to see. Okay. All right. Now, do any of you have any questions about the assignment that was due today? Those of you that didn't submit it, was the reason you didn't submit it because you didn't understand how to do it, or was it you just didn't get around to doing it? So tell me in a private message. Okay. Those of you who didn't do it, and you know who you are. Okay. Why didn't you do it? Was it because you didn't understand it, or you just didn't get around to doing it? Tell me in a private message so nobody else can see. Hello? Do you want me to name you by name? Oh, okay. All right, good. Okay, all right. I still need one more. Yeah, yeah, you did. You don't worry about. Okay, there's the other one. Oh, that's right. Oh, okay. Yeah, you sent me a message about that and I forgot. Yeah, that's a good excuse. So that's okay. Don't feel bad. Okay, so I apologize for wagging my finger at you because yeah, I did get your email where you did tell me about that and I forgot. So okay, that's an acceptable excuse. But the other one of you, that's not an acceptable excuse. So I will wag my finger at you. Okay. All right. So let's talk about tonight's homework. So the best way to do that is just to show you what I want you guys to do. Let me go into here again, and we get out of this and go into here. Okay, so this circuit that you see right here, this is what I want you guys to build, but I don't want you to do a Tinkercad version. I want you to do a real life version. And so we've got two separate circuits here, just because it's easier to do. I mean, you guys know, remember the other day we talked about it's possible to have two Arduinos in the same Tinkercad simulation? That works. Okay, so let's focus in on this guy on the right here. Let's ignore the guy on the left, at least temporarily. Okay, so what we have here is um, we have a battery. Let me turn on my annotations. So, okay. So we have one of these yellow motors. In fact, okay. So up until now, we've been using these guys. These are what I like to call the baby motor. These are the guys that they don't require very much voltage. They don't require very much current. So if you want to hook these guys up directly to an Arduino, okay, you can get the power from the Arduino to run this motor. You don't need any extra power source, and that'll be fine as long as you use this little baby motor. But if you use any other motor, you could ruin your Arduino. So this is the motor that you guys are going to be using for your homework tonight. This guy requires more current than the Arduino is capable of delivering. Now the voltage isn't a problem. This guy is designed to run on about somewhere between 3 to 6 volts. So let's pick the midpoint, 4.5. This guy is designed to run at 4.5 volts, but he can run on less. He can run as low as 3 volts, and he can also run up as high as 6 volts. So as long as you're somewhere in between that range, that's good enough. So the Arduino puts out 5 volts, which is perfect. That's exactly the right voltage for this motor. But the amount of current that this motor takes, the amount of electricity that flows through it is more than the Arduino can supply. So if you hook this up directly to the Arduino, you could destroy the Arduino. But that doesn't mean that you can't run it where it's controlled by the Arduino, and that's what we're going to learn today. And this is something that we've already talked about before. So if we look at this here, you'll see that we've got what I like to call the big battery, which is this guy. So I'm going to call him the big battery. And really, he's just 3 AA batteries connected together. So the total voltage here is 4.5 volts, which is just perfect for running this yellow motor. It's exactly the voltage that yellow motor likes to have. Okay, and the important thing is that this big battery, which by the way, I guess I should spell battery correctly, shouldn't I? This big battery is capable of putting out all of the current that the yellow motor needs. Okay, so what we're going to do is we're going to hook it up in a way so that the yellow motor is getting his power from the big battery, not from the Arduino. But we do want the Arduino to dictate when the motor comes on and when the motor goes off. That we want it to do. So how can we do that? Well, we use this thing right here. This is called a relay. And we have talked about these before. just not in a whole lot of detail, but I have at least mentioned them before. So the way that a relay works is really interesting and really important. And by the way, you guys have relays in your kit of parts. You have a thing that looks like this. Okay. Um, okay. So the way that a relay works is that you have this thing right here. Let me go to a little bigger text here. So this thing right here is an electromagnet. And so when electricity is flowing through it, then the magnet is on. When the electricity is not flowing through it, the magnet is off. Okay. And then this part right here, this is a switch that will either be in one position or the other, depending on whether or not the magnet is turned on. Okay. So there's a pin here, a pin here, a pin here, and a pin here. So if, let's see, I should have, okay, oh, here it is. Okay, so the one that I have, is white rather than yellow, but it works the same way. So if you pull it out of the breadboard and you look on the other side, you'll see there's a bunch of pins right here. Okay, and so these two pins that are separated by a greater distance away from the rest, these are the pins that this controls the electromagnet that's inside. Now, this electromagnet doesn't take very much current. So the Arduino can run the electromagnet. The Arduino can put out plenty of voltage to run the electromagnet. So these are the pins we're going to connect up to the Arduino. These other pins that you see right here, those are the ones that we're going to connect up to the big battery. So let's go back into here again. Okay. So if the Arduino is not powering the electromagnet, okay, then you can see that this pin and this pin are connected. So now I wish that they had done it slightly differently. So this and by the way, and there are two completely separate circuits. There's one on this side and there's one on this side. They're both completely separate. We're only going to work one of them at a time. Okay, so this pin right here and this inside here, there's a connection. So electricity could flow from here and it could come out here. And that's what would happen if if the electromagnet is turned off. So if you were to plug in a wire to this pin on your breadboard and this pin on your breadboard, you would find out that they are connected together. So electricity could flow through here as long as the electromagnet is turned off. But if the electromagnet is turned on, then this switches over the other way. And so this pin here corresponds to this guy over here. Okay, so if the electromagnet is turned on, then the electricity comes in here and it goes out here. It doesn't come out here. Okay, so you follow that? So if the electromagnet is off, the electricity flows like this. And then let me switch to different colors. So if the electromagnet is on, then the electricity flows like this. Does that make sense? So give me thumbs up or thumbs down if that makes sense. So in the on your reactions down the bottom, okay, good. So I'm seeing a lot of thumbs up. Okay, all right, very good, thank you. Okay, so that is how the Arduino can control the big motor. So what we do then is, I think, pretty straightforward. So we're just going to program the Arduino so that it comes on, and the way I've got it set up here, I've got it set up so the pin 7 is the pin that is being controlled. In fact, let me zoom in a little bit closer here. Okay, so when I want the yellow motor to run, what I'm going to do is I'm going to tell the Arduino to turn on pin 7. So the electricity is going to come up here and it's go to here. and then it's going to go through the electromagnet. It's going to come out this side. And so, and then it's going to flow along here, and it's going to flow along here, and it's going to go back into the ground. Okay, so the electromagnet will be turned on. So if the electromagnet is turned on, then we can see that the electricity from the battery will be allowed, it'll come out here and it'll flow through here and it'll come in here and it'll go and it'll come out this way and then it'll flow along here, okay? And then it'll come into the motor. So it's down a little bit low. I don't want to move my screen because then my arrows won't line up. But it'll come in through the motor, it'll flow through the motor, and then it'll come out here, and then it'll go back into the battery. And so the motor will spin. You see that pretty clear and easy way to do that. So now let me back off just a little bit. Okay. Okay. So by turning on and off the electromagnet in my relay, that allows me to turn the motor on and off, even though the motor is not getting its power from the Arduino. The motor is getting its power from the big battery. All right. So let's look at the code that I got in my Arduino. So remember, I've got two Arduinos. I've got two Arduinos here. So the way that I can handle this is I'm going to click on this Arduino. And so now that I've clicked on that Arduino, now when I click code, the code that I will see will be the code for this Arduino, not the code for the one on the left. Okay, so here is my code. You can see it's very, very simple code. So all I've told it to do, let's make it a little bigger so I can see a little bit better. Okay, well, all I've told it to do is I said set pin 7 high, wait for 3 seconds, set pin 7 low, wait for 3 seconds, and then repeat. All right, so let's see if that is in fact what happens. So let me zoom in a bit. Okay, I'm going to start my simulation. And it takes a little while to initialize. Okay, so what you can see here is that it's coming on and my simulation is running slow. You look at the clock here. Okay, the clock is running slow because a lot of people are all using Tinkercad at the same time. So you see I've got 0 volts, and if you look at the motor, you can see it's going at 0 RPM. Okay, and now in another, once this reaches 6, okay, there, it's up at 6 seconds now. So you can see now I've got voltage on my motor, and you'll notice that it's not 0 RPM anymore, it's more. In fact, let's zoom in a little bit here just so we can see it a little better. Okay, so I'm at 0 RPM right now. And my clock is running extremely slowly. So when this gets to 12, then my motor will come back on again. Boy, there must be a lot of people using Tinkercad right now. Okay, here we go. We're almost at 12. Now, bingo, there. You see the motor just came back on again. And I'm measuring the voltage there. And notice that the voltage here is not 4.5. It's actually a little bit less than 4.5. That's because we're losing a little bit of voltage due to the fact that we got a lot of current flowing. So if you take a battery, if you measure the voltage of a battery when no current is flowing, you'll get the full rated voltage. But if you measure the voltage of a battery when current is flowing out, you'll notice that the voltage drops a little bit. Actually, maybe sometimes a lot, depending on how much current is flowing. Okay, so what I want you guys to do right now is I want you to type in the chat box. I want you, if you think that you could take the components that you have in your kit of parts and you could make what you see on the screen right now, I want you to say yes. If you think that there's something you don't understand, and so you want a little more explanation, then type no. Okay, so I'm seeing a lot of yeses. Okay, good. All right. Okay, so now you're hopefully wondering what is the deal with this other guy over on the left side here? What is he doing? Okay, now this is not going to be part of your homework tonight, but you are eventually going to have to do it. So I'll show it to you just for grins, but don't worry about needing to do it tonight. I will give you lots of time to do it. But let me show you how this works. Okay, in this case, we have, instead of using a relay, oops, hang on a second here. My screen is doing funny things to me. Tell you what, I need to reset my screen. It's probably working okay for you, but it's doing some funny things for me. Okay, so what I've done is I've replaced the relay with a special kind of device called an H bridge. Okay. Now, I don't want to go into too much detail right now about what an H bridge is, but basically you can think of it like it's a relay, but it's a very special kind of relay. It's what we call a solid state relay. Okay, so think of an H bridge as being a solid state relay. Okay, now I realize that many of you are saying solid state. What does that mean? Okay, well, let me show you what it means. Okay, so when you guys do the homework tonight, when you build this device right here, I want you to listen. I want you to put your ear right next to the relay, and you will hear every time that the Arduino turns on the electromagnet, you will hear a click. And every time that the Arduino turns off the electromagnet, you will hear a click. Okay, because what's happening is inside the relay, there is there's a little piece of metal that's going up and down and up and down. So when you turn on the relay, it goes up. When you turn off the relay, it goes down. Okay, so you actually have a piece that's physically moving, and so that's how relays work. Now, what if we want to run the motor, and let's say we want to run the motor on the right side here. Okay, but instead of running it at full speed or half speed, what if I want to run it or I'm sorry, instead of running at full speed or zero speed, what if I want to run it at half speed? Or what if I wanted to run it at 37% speed? How did we do that when we were doing the baby motor? How do you make a baby motor run at 37% speed? Somebody unmute yourself and tell me. What do you do to the baby motor to make it run slower? Do you lower the voltage, or do you do another trick? You guys just got through doing this in the homework assignment.
You use pulse width modulation.
Thank you. That's what I was looking for. If you want to run a motor at a slower speed than full speed, you don't turn the voltage down. What you do is you use pulse width modulation. So you give it the full voltage, but you give it in little bursts. So it has a little burst of voltage for maybe a half of a microsecond, and then it's off for 1.5 microseconds, and then it's back on for a half microsecond, and then off for half a microsecond. Actually, millisecond is what it is. It's on for half a millisecond and then off for 1.5 milliseconds. So by changing the width of the pulse, that is how you control the speed. Now, if you try to do that with a relay, if you try to pulse width modulate the relay, you will destroy the relay, because inside the relay, you've got that little thing that's going up and down and up and down. Every time it moves, there's a little wear and tear. I mean, these things are designed so they can move they can move several thousand times, but they're not designed so they can move several million times. So if you give it a pulse width modulation, then that thing is going to move so many times. I mean, it's going to move like about 500 times per second. So if you run your motor for 1 minute, okay, you've just used up a couple thousand cycles of this thing's life. And so after a couple minutes, your poor relay is just going to break. It's going to say, oh, sorry, I can't handle this anymore. And so this thing inside the relay that moves back and forth, it's going to break. Okay. And by the way, it's also not going to work right, because the time that it takes for the switch to go from here to here is more than a millisecond. And so if you give it the command to move up here, but then before it reaches there, you give it the command to move down. And then before it reaches there, you give it the command to move up. That poor thing is going to be sitting there saying, make up your mind. Do you want me up or down? I can't handle this. So if you try to pulse width modulate a relay, one, it's not going to work. And two, you're going to break your relay. Okay. So that's why I have this note right here. Never use pulse width modulation on a mechanical relay like this one. Okay. Important note, exclamation mark. Never you try to use pulse width modulation on a relay. You will destroy the relay. Okay. But an H bridge is a whole nother matter. An H bridge is a solid state relay. Okay. So what's happening inside the H bridge is something that I'm not even going to try to take the time to explain right now. I will go into it later, but now is not a good time to do it. But inside the H bridge, instead of having something that's physically moving, okay, there are no moving parts. And so if you want to pulse width modulate the H bridge so that you want your motor to run at half speed or quarter speed or 68% speed, you can pulse width modulate an H bridge. It can handle it. A solid state relay cannot. Okay, so let's just go and let's just look to see what happens. And then I'm going to let you guys go in just a minute. But okay, so what we've got here is we've got our H bridge basically serving the same function as the relay does. Now the wiring is a little bit different. I do not intend to talk about it today. Today, for your homework today, I want you to only do the relay. Don't do the H bridge. But I am going to show you how the H bridge works. So you'll notice I've got it hooked up. Well, actually, don't even worry about how I've got it hooked up. So I'm pulse width modulating it. Okay, so instead of just running the motor at full speed and then 0 speed, I'm actually running it at partial speed. And what you're going to see in a minute is that not only am I running the motor forwards at various speeds, I can also make the motor run in reverse. So check this out. This is cool. So I'm going to start the simulation. Okay, so there it goes. So it starts off at 0, and now I'm running it at about 20% speed. And now I'm running it up at about 40% speed. Now I'm running at 60% speed. Now I'm at 80%. Now I'm at full speed. So this motor is now running at full speed. Okay, now watch what happens next. I'm running it in reverse. It may not be obvious, okay, but it is now running in reverse. And these pulses, instead of being positive pulses, these are now negative pulses. So I'm running it in reverse. So now I'm up at about 80% speed right now in reverse. Okay. And my clock has slowed down. Okay, so that was 60%. Now I'm at 80%, but I'm running in reverse at 80%. So I apologize for the fact that my Tinkercad clock is running really, really slowly. Okay, so now I'm at full speed in reverse. So it's going to run there for a little while. And then now it's stopped. Okay, now it's back at full speed again. Or I'm sorry, now it's back in forward motion at 20% speed and then 40% speed and so forth and so on. Okay, so now it just repeats the cycle. So you see, is that cool or what? Okay. So with an H bridge, you can pulse width modulate it. So you're not stuck with just having full on or stop. You can run it at various speeds, and you can also run it in reverse. but I'm not going to take the time today to explain how reverse works. So next time we meet, that's when we'll talk about H bridges. Your assignment for tonight is just to get the relay working. Okay? Now, if you look on Canvas, you're going to see something that might possibly confuse you. So let's go on Canvas, and let's make sure you guys see what's up here. Okay, so what you guys are working on is actually your midterm exam. So getting the relay working, it's only part of the midterm exam. The full exam is to get both of them working. Okay, but you don't need to worry about doing it by the next time you meet. This is going to be due next week on Saturday of next week, not this coming Saturday, but a week from this coming Saturday, that's when this is due. So you should have plenty of time to do this. And by the way, if you would like to play with this, my Tinkercad version, if you click on this link, you can make a copy of my Tinkercad program and you can play with it. And I highly recommend that you do that. Okay. So for tonight, just get this one working, and you don't need to submit anything to me to prove to me that you've got it working correctly. Just get it working and satisfy yourself that it's working. And then what's going to happen is next time we meet, which will be with Cottonwood's weird scheduling, I don't know. Do we meet on Monday or do we meet on Tuesday? Anyway, next week when we meet again, what I'll do is I'll explain how the H bridge works. And so then by the end of the week, you should be able to do both of them. Okay. So don't worry about this one for tonight. Just worry about this one. Okay. Are there any questions? Okay, so I realized that I hit you with a lot of new stuff today. At least for some of you, it's new. Remember that everything we did today was recorded. I will put this recording up on Canvas later tonight, so you can go back and you can watch it again if you want. So your assignment over the long weekend is basically get working with the relay. Now, if you want to start working a little bit ahead, if you'd like to try the H bridge, go ahead. Look at the way that I've got it hooked up on Tinkercad, and then if you just kind of duplicate in real life what I've done in Tinkercad, you could get it working. You might not understand why it works, but by copying what I've done, you could get it working. And so, hey, if you're bored this weekend and you want to go ahead and jump ahead, you have my blessing. Okay, well, if you don't have any questions, then I'm willing to call it a day. And so you can go ahead and type "bye" in the chat box and you can head out. Now, if you did have a question, but you didn't want to ask because you knew it was being recorded and you're shy, which I realize is okay, I'm going to turn off the recording. And so then we can talk without it being recorded so you won't be embarrassed.